Hey, good morning, everybody. Welcome back to DX Radio Shop. So, on the bench today is a TRC 495. This will be our beginning stage today of radio repair. I'm not going to do it just yet. We're going to do a video by itself for it. Right now, we're just going to kind of do a morning net, do a little hot topic chat if anybody would like to do so. I'm just getting the bench all set up for what we're going to do today. So, if anybody wants any topics to talk about, now will be the time for our wonderful morning net. So let's do our check-ins to see if anybody's around today and see how our Wednesday morning is going. We have Mr. Matt Leadfoot Michael. How are you guys? You're going to be on my way today, Matt? Perfect. You going to stop by and see me, or you just passing by the area? Let me know. I'll jump on the air and see if we can't make contact. If you're passing by or whatever, but we'll be here most of the day. I got to run off for a little bit and go down to Penny Ann, but I plan to be here most of the day today. Hello, Steve. Hello, Stanley. Good morning to you guys. We got 5 check-ins already. That's wonderful. If anybody else wants to check in, say hello, say good morning, put a thumbs up. Good morning, Rick. Morning, James. How are you? Good to see you on. These are old radios, but they are great radios. So I'm going to work on this one today, and there we go, nice little close-up for you guys, and get this thing rocking and rolling. This one here has no receive audio, so I can only assume probably an output capacitor, probably more than likely. We'll see what happens. Well, Matt, Leadfoot says Matt's going to do a drive-by. Good morning, Jim. Yeah, if you had time, stop by. Goodness gracious, that'd be great. Absolutely. Hell, feels nice out. I throw a steak on the grill for you. Not today, though. Yeah, we'll see if we can make contact. Shoot me a text when you're around the area. Yeah, the Navajo bases were really good. These ones were nice. I remember getting one of these when I was a little kid for Christmas. These are great radios. Yeah, but the Navajos are really nice. Like I said, we're going to do a video on this one. Right now we're doing kind of doing like a morning Raichu check-in. And we'll start this one shortly after. Couple inches of snow this morning out here. We already shoveled our driveway down. How's everybody else doing? Everyone keeping warm and whatnot? Hey, there you go, Matt. Sure. Punch in your GMRS repeater onto it and see if it will take. That's all you can do, really. See if it'll allow you to transmit. It should. I mean, for example, just type in like, say, I don't know, 467.000. Just type that in your VFO mode on your Baofeng, and then hit transmit. If it transmits, then you're good to go. If it don't, well, then you're not going to be able to utilize that. But most Baofengs come fully operative with that, so you shouldn't have to worry about not transmitting, obviously. Hello, Bhaskar. How are you? Jim, how are you? Ralph, how are you? Good morning. "8 degrees in Toledo, Ohio." Yeah, I'd say that's a little cold. Where's my phone? I just had my phone. Oh, here it is. It is currently 19 degrees here. How's Boxcar today? "3 degrees at Leadfoot." Wow. Way down there in Illinois. "44 down there in the sand pile." Yeah, well, I'd love to have 44 degrees up here, Rick. About this snow away. That's okay. Anyway, so what other hot topics we got out here? Michael says it's like 97 at Rick's place. What do you want to discuss today? Let's see. What could we discuss today? "35 degrees down there in Dallas." Well, we have an email here. We're going through our emails. We got lots of questions as well. All right, one of which says, "Can you explain the blocks on an oscilloscope? What do they mean when you mention divisions?" Okay, so, good question. You don't need a voltmeter for your radio, Rick. Okay, so on an oscilloscope, the guy is asking about, this comes from San Jose, California. He says, one question says about the scope. He wants to know about the scope. Let's answer that one first, and we got another one here that wants to know what's the common failure on a Astron or Pyramid power supply. Okay, well actually let's do the power supply first, because the scope, I'm going to show you a couple things here. So the power supply, hello Aaron, good morning. 45 degrees down there? 46 degrees, wow. So your power supply, typically what happens with those is the regulator chip, which is like an LM324 regulator chip, tends to fail. And in fact, we had a guy here the other day, one of my friends stopped by with his, the power switch had failed. For whatever reason, his power switch failed. So we replaced it, no big deal. But the most common failure on a power supply for the Pyramids and the Astrons, which are very similar circuitry, are the regulator chips. Second most common would be the TIP29 regulator on the board as well. But most likely it's going to be that 14-pin chip. Those chips are very sensitive. And so what you do, they don't come with a socket, so you can buy yourself a chip socket. So you unsolder the old chip, put a socket in place, and then pop your new chip in there. So if it ever goes again, then it's a plug and play type setup. Now it's easy to replace. Now as far as a oscilloscope goes, let me get my camera here switched. How can I do this? Let me show you, because explaining it is going to be simplified for me, but if you don't know and you're asking that question, then I have to show you so you get a better understanding. Some people are more of a hands-on type deal, so let's do that. Okay, here we go. Okay, so here's your oscilloscope. Now, that is your flat line. Okay? Now, what you do is when you have a division, you want to know about the divisions. When you mention about divisions, how do you know what to look for? So each block, one full block is your positive and your negative side. So when you key up, you're going to have two blocks. One here, one here. So that comes now to be your two division. Okay? Because you're going to have a positive and you're going to have a negative. So this becomes now two division. 1 and 1 is 2. If you have 2 blocks up and 2 blocks down, that's 4 division. And if you, obviously if you go up, it's 1, 2, 3, 4 up, and 1, 2, 3, 4 it'll be 8 division. So each block is division provided how you have your oscilloscope set up. Now, if you have those little graduals in between, they are your tenths. So let's say you've got 1 and 1 here, that's 2 division, but let's say you've got a modulated carrier or a modulated signal that peaks up and down, right? So you got your nice little sine wave. So let's say you come up this way and you come down, that's 4 divisions. But maybe if it's not an even 2 blocks up, 2 blocks down, it could be a couple of these little lines. Let's say it's at the second one. Then you're going to be, you've got 0.2 and 0.2. So now that becomes a 4.4 division. 1, 2, 3, 4 plus 2 graduals plus 2 graduals, 4.4 division. So that's how you calculate, how you read your oscilloscope rather, is each block, positive and negative, becomes a division. So you got 1, 2, so that's going to be 2 division. So when you hear somebody say, oh, I got, block here, that's only 1 division, they don't know how to read a scope then. One block, positive and negative, that becomes a 2 division carrier at that point. Okay? So hopefully that will answer your question, Mr. Joe. Oh, got another question about the scope. Okay, another one says here, how do we know what your cycle per division is, okay? Well, a cycle per division now, let's say you have a sine wave here, comes down, and it comes back up. Your cycle per division would be in between your peak to your next peak to your next peak. So if your peak, we'll say, has come up to about here, and then comes down, it comes back up here, and you would count your cycle per division in between here. So the center of this position, then let's say it's over here, so it'd be 1, 2, 3 cycles per division. So if your peak met this point, came down and met this point, then it'd be 1, 2, 3 cycles per division. So it goes between your peak to peak is your cycle per division. Your modulated percentage carrier would be from your peak to peak, and your minimum voltage carrier to minimum voltage carrier. So let's say your peak is 3 up and 3 down. Well, that's going to be a 6th division. Let's say you're at a 0.1 and a 0.1 above and below. Well, that's 0.2. So it'd be 6 minus 0.2 equals 6, and then 6 plus 0.2 would be 6.2. And then you divide the two, and that'd be your percentage times 100, which gives you your percentage of modulated carrier. These formulas are very important to know, guys. If you don't understand a formula and you're just copying everybody else's videos to see what the waveform looks like, you're not going to understand it. Which is why it's important that we go here to our spectrum analyzer, because the spectrum analyzer will show you way much more that an oscilloscope cannot show you with a naked eye. So it's very important that you have a spectrum analyzer on hand. And don't use that computer stuff. They're not really accurate at all. You got to get it through a coaxial line, through an RF sampler. You got to be able to pick up a signal. All that computer software stuff, it's just fancy stuff to make the customers look like, wow, this is cool, man. You got a big screen with all these, fancy graphs and modulated stuff. When you talk, I can see you, speaking to it. That's so cool. It's just SDR, just software-defined radio. That's all it is, guys. And they're not really accurate. You get them close, yeah, but it's not really accurate at all. So if someone's got a computer screen that they're using that kind of software to measure your spectrum analyzer, all your RF signals and whatnot, it's okay to an extent. They're not bad, but you got to get a good spectrum analyzer, a real analog spectrum analyzer. You can use digital, but not the computer stuff. Get a real spectrum analyzer machine. If you're going to spend the money, spend the money. It's $1,500 for a really good spectrum analyzer, and that's what you need. You don't want to fool around with some SDR nonsense because you don't know what you're really going to have. They can tell you one thing, I can make that thing read all kinds of stuff all day long, and when the customer gets it back, you're going to find out, gee, someone said I'm splattering. They saw me on their waterfall and it says I'm off. And then you're going to argue with them and say, no, it's on, because remember I showed you. You got to have real good machines. You got to have honest machines. Which brings me to another point I wanted to bring up. We were talking about this the other day with somebody. So when you have a equalizer or like a mixer in line with your equipment, there's no harm in it, but if you want to enhance it much better, but have a clean signal to start with. And when you tune in a line of radio, let me rephrase that. Professional shops like myself, we align and tune radios. With these little hack shops, when they peek and tweak your radios, and they put them on these equalizers, and they show you, oh, look how clean this is, guys. Yeah, because they have it on equalizer. And so what happens is when you go to do that and you enhance all your modulation on all that stuff, and then you give the radio back to the customer, and they say, hey, I'm splattering, man. Someone said I'm really splattering bad. Well, now it becomes a argument again, because that wannabe tech's going to tell you, oh, no, I showed you. See, it was clean. Well, yeah, because you got it hooked up to your mixer, your equalizer. And the customer's not going to have all that stuff. He just wants his radio to work and sound clean. And the point is that, here's the biggest point. If you have to add that stuff to your radio to improve your radio, then you got to go back to square one and start over. Your radio system should be aligned and tuned correctly, have a very good antenna, low SWR, everything's grounded excellent, and you'll have yourself a really good setup. You don't need an equalizer to enhance that. If you want one to give a little bit more of that broadcast sound,
okay, but start with a good, clean station. If you're looking to get one just to clean up the dirtiness of what you have, and you're still splattering, you're just wasting time and money. You're just spinning your wheels. And I see that a lot of times. A lot of these shops will do exactly that, and that's not a good thing. And that's where you have dishonesty. So those are my hot topics, I guess. Anybody else got any topics right quickly before we move on? What am I doing up so early? Oh, I get up early every day. It's wondering how to get on here every day. First thing in the morning. I get up every day because the kids got school. So I'm up every day at 5:30 to 6 o'clock. What is the most common problem with Tektronix scopes that won't power on, just clicks? I'm not sure. I don't repair scopes, so I couldn't tell you that, honestly. I would assume you gotta check to see what's going on in the power supply section first off, or if it's just clicking, maybe the CRT had failed. I really don't know. I don't repair scopes, so I couldn't tell you that. I got a guy who does all that for me. Could I do one? Sure, if I had a schematic here, but will I do one? No, because the old analog scopes are high voltage, and I don't feel like getting zapped, so I'll stay 6 feet above the ground. So I don't mess with those things inside. There's a lot of high voltage with the CRT module, so I don't mess with those. Couldn't answer you on that one, buddy. Other than I would assume either power supply issue, or I would figure the CRT is probably just not functioning, and the rest of it's trying to boot up, but it can't because the CRT can't display nothing. That'd be my guess. Usually when they go, it's usually the CRT that fails because it's an old unit, but I really don't know. No. All right, guys. Well, 7:21. We're gonna move on here so we can get things rocking and rolling and get this old Radio Shack base station up and running. Customer says no receive audio. It's got no sound, so it's probably gonna be a output capacitor more likely. But we're gonna check the most obvious. We're gonna check the microphone, make sure there's no broken lead in the receive with this, and then we're gonna check the external speaker jack to see if it's an internal speaker problem, and if that's not the case, then we got to go to the audio strip and check the output capacitor. And I'm going to show you a simplified trick to identify if a cap is possibly bad by using your voltmeter. And a lot of guys don't believe this, and I don't care what they believe, because guess what? It works. So it's a quick, easy test to identify if you have something else with the capacitors. You can do a quick, simple test with that. So, and I will show you in the video when we begin this here shortly. So stand by, guys. We're going to end this video and move on to the next one. Catch you all later at the DS Radio Shop. Thank you all for checking in. We got quite a few people in here for sure. And we'll see you guys